So you may have already noticed that on the statistical tables there is a table 2, and this is I'm just going to show you an example of where you'll use this table. So if you are given the probability, we're trying to work out the value of x this time. So previously we've been given this value and we're trying to work out, do it the other way around. But now if we're given the probability here, the probability that x is less than another value, then we are going to use table 2 to look for this 0.75, this probability. So here's 0.75. And we can see that we've ended up on 0.6745. And this is for x normally distributed with a mean of 25 and a standard deviation of 1.25. So what we've got to do is transform it to the standardised normal distribution, like we have done previously, but this time we don't know the value of x. That's what we're trying to find. So we will set it out like this, and you can see the 25 relates to the mean and the 1.25 to the standard deviation, and this 0.75 is from the probability on the previous slide. So we worked out, we know from the previous slide that this is the number that corresponds with the 0.75 probability. So we can now replace, well, we can equate this part here to this part here, which is what's happened here, and work out what x is. So this is perhaps the trickiest part, which I haven't put in here, but to work out what x is, the first thing we need to do here is multiply both sides by 1.25. So we would end up then with x take 25 equals 1.25 times by 0.6745. And then the second thing we do is add 25 onto both sides. So actually the value of x we would get from 1.25 times the 0.6745 and then add in on the 25 on the end. And just make sure you do the multiplication first. And if you do all that, you should get this answer here. So there's two different tables. The first one is when you are given or can calculate z values and you're asked to find the area under the curve. You're asked to find the probability. Table 2 is used when you are given the probability. So we were given the 75% or the 0.75 probability there, and we needed to find the corresponding z values. So we're just going to look at an exam question here, which will involve both tables. And if you need to, maybe pause just to read the question. But the key information we're going to take from here to start with is that we've got a mean of 5.6 and a standard deviation of 1.3. And the government recommends that adults should have a total cholesterol level below 5 millimoles per litre. So what we're going to do is try and work out the probability that a randomly chosen adult in the UK has a total cholesterol level below 5. So we're going to have to standardise it. We know it's a normal distribution because it's told us over here. And the probability that a randomly chosen adult, so probability that x is less than 5 is going to be the same as the probability z being less than 5, which is our value. Take away our mean, 5.6, and divide all of that by not all of it, sorry, just the numbers at the end, ignore that bit, by 1.3. So that will give us the probability that z is less than negative 0.6 over 1.3, which I will stick into my calculator. And we get minus 0.46, negative 0.46. So what we need to do now is think about our normal distribution. So we are looking for the values that is less than negative 0.46. So that is going to be the same as 1 take away the probability of z being less than 0.46. So I'm looking for 0.46 and looking on my table, that gives me a value of 0.67724. So 0.67724. So if I put all that in my calculator, 1 take away 0.67724, I get 0.322. 8 if I round it to 4 decimal places. So this next question asks us to show that approximately 1 in every 3 adults in the UK has a total cholesterol level within 10% of the mean total cholesterol level. So 4 marks. We know the mean is 5.6. So 10% either way. We can multiply it by 1.1 to get 10% more. And that gives us 6.16. We can also multiply it by 0.9. Oops, 5.6 times 0.9. Basically, we're just adding 10% when we're subtracting 10. And that gives us 5.04. So we now want to work out the probability that someone is within this range. So we're going to have to do the probability that they are less than 6.16 and then take away the probability that they're less than 5.04. If you imagine it on a curve, we want to work out this part and then take away this part, and this will give us the bit in the middle. So we need to standardise it first of all. So we'll look at this one first. So we need to do the probability that x is less than 6.16 is the same as the probability z is less than 6.16. Take away 5.6, which is the mean, and divide it by 1.3, which is the standard deviation. And I think when we do that, we end up with the probability that z is less than 0.43. Sorry, lots of noises in the background. And then we'll do the probability that x is less than 5.04. And for that, we will end up with the probability that z is less than 5.04, take away 5.6, which is our mean, and divide it by 1.3, which is our standard deviation, and that will give us the probability that z is less than negative 0.43. So I'm going to change colour because it's getting a bit tricky to read. So now what we're looking for is the difference between these. So to the probability that z is less than 0.43, we can get that from our table, and we will get for that 0.6664. The probability that z is less than the negative number, we need to do 1 take away the probability that z is less than 0.43. So altogether we have got 0.6664 take away 1 take away 0.6664. And if we stick that in the calculator, being careful to add these, if we're taking away a negative, we're actually adding. So we will have 0.6664 plus 0.6664 and then take away 1 gives us 0.3328. And 0.33 is close enough to show us that approximately 1 in 3, or 33%, or as a decimal 33, in every adult in the UK has a total cholesterol level within that range. So this question is similar to the questions that we were looking at the very beginning of this video, where we're going to use table 2. We're looking at the cholesterol exceeded by 75% of the adults. So 75% I'm going to find on here 0.75, which is 0.6745 on the table, 0.6745. But actually, because we're looking for the cholesterol level exceeded by 75% rather than the shade bit, which is less than, we're going to have a negative value for this because we're looking for 75% of adults to be on the right hand side of the graph. So what we'll end up doing is we're looking for a value. We will do the standardising, so take away 5.6 and divide it by the standard deviation, which is 1.3, and we know that that is going to be equal to negative 0.6745. So then to work out the value of x, we've just got to manipulate this a little bit, move things around. First thing we'll do is multiply both sides by 1.3, which will get rid of the 1.3 off of here. So we have x take away 5.6 equals 1.3 times negative 0.6745, which I think gives us negative 0.87. So there's a times negative 0.87685, and then we'll add 5.6 onto both sides, which will get rid of it from this side, and we'll end up with 5.6 take away 0.876, etc., which will give us a final answer of 0.47-ish, give or take. And that is the answer that we're looking for, probably with the units as well.